In section 6.1, we're going to learn how to find a greatest common factor, or for short term, we call it GCF. And we're going to learn how to use that GCF to factor by grouping later on in the section. To start off, these definitions are really good. The top three are basically saying that to factor something means to write it as a product. And then at the bottom, prime factorization of an integer, to write an integer as a product of two or more prime, that's the key, prime numbers. So 12, for instance, we wouldn't want to just say that 12 equals 3 times 4, because 4 is not prime. The prime factorization of 12 would be 3 times 2 times 2. To find the greatest common factor, we're going to write the prime factorization of these numbers and variables, and we're going to see what each term has the most in common between each term. So 12, the prime factorization of it would be 2 times 6, but 6 isn't prime, so we'll say 6 is 2 times 3. 2 times 3. To write the prime factorization of 90, I think I'm going to do a factor tree first. 90 is 2 times 45. 45 is 5 times 9. 5 is prime, 9 is not. 9 is 3 times 3. And everything is prime, so I'm going to write them in numerical order. We could also call this 12, we could call that 2 squared times 3. And 90, you could call that 2 times 3 squared times 5. But we're not going to make you do that. That's just another way to think about it. I prefer to just think about it like this. To find the GCF now, we're going to circle the factors that both 12 and 90 have in common. So they have a 2 in common. They also have a 3 in common. So that would make the GCF 6, because 6 is 2 times 3. To find the GCF of 24a cubed b and 36a to the 4th b, I'm just going to write the prime factorization of both of those items. So 24 would be 2 times 12. But 12 isn't prime. 12 is 2 times 6. But 6 isn't prime. 6 is 2 times 3. And you can double check yourself if you're not confident about that and just put 2 times 2 times 3 in the calculator. And it will give you your answer. A cubed is just a times a times a. And then we have a factor of b on the end. So for 36, a to the 4th b. 36 is 2 times 18. 18 is 2 times 9. 9 is 3 times 3. A to the 4th, we're going to write 4 a's out. A times a times a. And then b on the end. So I'm going to circle what repeats in the top and the bottom, what both things have in common. They have a 2, another 2. They don't have a third 2 in common. They do have the number 3 in common. A, and A. They have three A's in common, and then they have B in common. So the GCF is 2 times 2 times 3 times A times A times A times B. So we can say that that is 12 A cubed B. So now we're looking at the GCF for 3 different terms instead of 2 terms. So I'll start by writing the prime factorization for all of these. 27 we can write as 3 times 9, but 9 is not prime. 9 is 3 times 3. And again, remember, if you're having trouble writing that out, you could use a factor tree. X squared is x times x. We have one factor of y, and then 2 factors of z. 6 is 2 times 3. Those are both prime. One factor of y and one factor of z. 24, I'm going to use the factor tree on this just to show you that we can do that. 24 is 3 times 8. 8 is not prime. 8 is 2 times 4. 4 is not prime. 4 is 2 times 2. So we could write 24 as 2 times 2 times 2 times 3. And then we have one factor of y and 4 factors of z. So let's look at what these 3 terms have in common. They don't have a 2 in common because the top one, 27, didn't have a factor of 2. They do all have a factor of 3. And they don't have an x in common. They have a y in common, and this is going to be kind of wonky the way I circle it. And they all have one factor of z in common as well. That's really wonky the way I circled it. So the GCF would be 3 y z. This one looks a little different, but it's fun. It's two different terms. We have 8 times 2x minus 3, and then we have 2x minus 3. Now 8 times 2x minus 3, really that's already factored out for us, but do understand it's clearly saying, now I guess you could rewrite the 8 as 2 times 2 times 2, and then times 2x minus 3. And then 2x minus 3 for our other term was already completely factored. So it looks like the only thing they have in common are these factors of 2x minus 3. Now that we know how to find a GCF, we're going to learn how to factor a GCF out. We have some steps for factoring out a greatest common factor. You first have to identify what it is, what each term in the polynomial would have in common. And then, now, step 2, write each term as a product of the GCF and another factor. Basically means once you find out what that GCF is, divide each term in the polynomial by that factor, and remove the GCF from that polynomial. We're just going to do a couple of exercises first. Use the distributive property to multiply, because really factoring is the exact opposite of multiplication. So 4 times 3x minus 7, that's already factored, because remember, factor basically means to to take something and make it multiplication. But let's see, 4 times 3x minus 7 would give me 12x minus 28. Okay, now that we have distributed, let's turn around and factor it back out. So to factor 12x minus 28, we want to define the GCF between those two terms. And we can write it out the way we did in the previous problems. 12x is 2 times 6, which is 2 times 3. And then we have a factor of x. And then listing out all the prime factors of 28, you got 2 times 14, but 14 is not prime. 2 times 7. Okay, so what we have in common is 2 factors of 2, which means the GCF is 4. So now to factor out that GCF of 4, I'm going to put 4 in front of some parentheses, and then I'm going to divide 12x and 28, or really negative 28, by 4. So 12x divided by 4 is 3x, and then negative 28 divided by 4 is 7. So that's factored. Once you have really practiced factoring out a GCF, you're not going to really need to write out that prime factorization every single time like I'm doing right here. Eventually, once you've practiced, you'll just be able to look at 6x and 14 and say, those are both even numbers. They got at least a 2 in common, and that's the biggest thing that they have in common. But then again, if you're not certain, by just looking at 6 and 14, of course you can write out these prime factorizations. But 2 is what they both have in common. So with the GCF being 2, I'm going to put it in front of some parentheses, and I'm going to divide both 6x and negative 14 by 2. So 6 divided by 2, and look, if you have to do this in the calculator, by all means. But we get 3, okay? And there was no variable in that GCF. It was just a 2. So when I say 6x divided by 2, the x stays with the 3. Okay, so now 14 divided by 2 is 7. And we're done with that. So I'm going to try to determine this GCF by just looking at the trinomial. 14, just in my head, 2 times 7. See if any of those numbers that I just said goes into 21. 7 goes into 21. 3 times 7 goes into 28. So numerically, we can pull out a 7, and then each term has an f. So as far as the variables go, as long as each term has that same variable, you can pull it out and pull out the lowest power of it that you see. So we see an f in all 3 terms. The lowest power that we see is this first power on the end. Okay, so I'm going to divide every single thing by 7f. So 14 divided by 7 is 2, and then f cubed divided by f. Keep your base, subtract the exponents, we get f squared. 21 divided by 7 is 3. F squared divided by f, again, keep your base of f and subtract the exponents. So 2 minus 1 is f to the first power. 28 divided by 7 is 4. And f to the first divided by f to the first. Keep your base, subtract your exponents. That's really f to the 0 power, f to the 0. Anything to the 0 power is equal to 1. But also you can just say, well, f divided by f, something divided by itself is just 1. So 4 doesn't get an f with it. We took that first power completely away, and we are left with 2f squared plus 3f plus 4. Looking at 20m cubed into the fourth, 5m squared n squared. 20m5, let's look at that first. 20 is 2 times 10, 4 times 5, 5 times 1, 5 is prime. But 5 goes into both 20 and 5, so we can pull out a 5. And then both terms have an m in common. And you will pull out, or the GCF will be the lowest power of it that you see. So we see a power of 3. We also see a power of 2. 2 is obviously smaller than 3. Okay, and then as far as n goes, we see a power of 4, and we see a power of 2. 2 is smaller. So let's try factoring that GCF of 5m squared n squared completely out. Okay, so I'm going to write it down, and then I'm going to open up some parentheses. 20 divided by 5 is 4. M cubed divided by m squared. Keep your base of m, and then 3 minus 2, I'm getting that from right here, is 1. So we're going to have just one power right there, and I'm not even going to write a 1, okay? N to the fourth divided by n squared. Keep your base of n and say 4 minus 2. So n squared plus 5 divided by 5 is 1, and m squared divided by m squared is 1. N squared divided by n squared is 1. So we're just left with 1. So let's look for the GCF between a cubed and 2bc. A cubed is a times a times a. And then 2bc, that's, prime. A cubed and 2bc have nothing in common. There is no GCF. And you can't pull the GCF and factor it. And when you can't factor something, it's prime. So there we go. Be careful on this one. We have 4 terms this time. So let's come up with a GCF first. Number-wise, there is an 8, a 1, a 6, and a 1, so really can't pull out a number. There's an a squared, a cubed, a to the fourth. The lowest number that I just said was a squared. Okay, let's see if everything has a b. We have a b to the first, b to the fourth, b squared, b cubed. So b to the first is what the lowest power was. So if I'm going to pull out an a squared b, the number in the front this time is going to stay. There wasn't numerically there wasn't a GCF as far as the numbers go, so we don't divide them by anything. So 8 stays the same. If I am saying a squared divided by a squared, that completely goes away. And if I'm saying b divided by b, that goes to 1 as well. So on to the next term. A cubed divided by a squared. You're taking 2 a's away from these 3 a's right here. So that leaves you with a to the first. And b to the fourth divided by b to the first. You have 4 b's and 1 b. So if you take 1 b away from the 4, you're left with b cubed. Moving right along, the negative 6 comes down. A cubed divided by a squared is a to the first. B squared divided by b is b. And then on the end, a to the fourth divided by a squared is a squared, because you say 4 minus 2 equals 2. And then b cubed divided by b You got 3 b's and you got 1 b. You take 1 b away from the 3 and you're left with b squared. And you're done with that. So on the next page, let's look at this statement because they really say it better than I can. So usually it is advantageous to factor out the opposite of the GCF, so factor out a negative, when the leading coefficient of the polynomial is negative. Well, what does that even mean? Well, the leading coefficient right here on this one is -3. It's the number in the very front. And it's negative, and when it is negative, pull out a negative with your GCF. So if I were to just factor out a 3g, and I'm actually going to start on part B first. If I were to factor out a 3g from -3g to the fourth minus 3g squared plus 9g, -3g divided by +3g is -1, because -3 divided by +3 is -1. And excuse me, that's a g to the fourth divided by a g to the first. I forgot about that. So -g cubed. 4 g's, you're taking 1 away, okay? So now -6g squared divided by 3g gives you -2g. And then +9g divided by 3g just gives you a +3. So that would be if you just factored out the GCF. But what we're suggesting is that when that leading coefficient is negative, instead of factoring out just the GCF, you factor out a negative with it. So the GCF was 3g, so instead factor out -3g. So what does that look like? Well, it just basically changes the sign of everything that was on the inside. Let's try it out. -3g to the fourth divided by -3g now gives you a +g cubed. -6g squared divided by -3g gives you a +2g. And 9g divided by -3g gives you a -3. So notice how we look very similar. Our insides are just opposite signs. So let's factor out the opposite of the greatest common factor on the next two problems, which just means, okay, well, what's the GCF? B cubed, b squared. The GCF is b, but instead of factoring out the GCF of b, the opposite of the GCF would be -b. So let's factor out a -b. That would give us a +b squared if I said -b cubed divided by -b. Now if I say -2b squared divided by -b, that gives me a +2b. And now 5b divided by -b would be -5. Here, a -2, a 5 numerically. There isn't a number that they all have in common. There isn't a variable that they all have in common. But I can take out a negative since that leading coefficient was -2. If I took out a -1 from everything, I would be left with 2u, -5v, and a +w. And there really wasn't a greatest common factor, but the leading coefficient was negative, so I did decide to pull out a -1. Factoring out the GCF, 7 times x squared plus 1 6y times x squared plus 1. Well, I'm going to remind you of something that we did earlier where we listed the items, the terms, and then we wrote the prime factorization of everything. And we did one kind of like this. 7, we can't, 7's prime, and then we can't factor x squared plus 1. 6 is not prime. 6 is 2 times 3, and then times x squared plus 1. Now, numerically, 7, 2, 3, nothing repeats there, but the factor of x squared plus 1 repeats. So there's a GCF of x squared plus 1. Now, if we factor out x squared plus 1 from the polynomial up here, if you take it away from the 7 times x squared plus 1 minus 6y times x squared plus 1, you're left with 7 minus 6y. How in the world? Imagine, though, if you literally took x squared plus 1 away, what they have in common away, what are you left with? Well, you're left with 7 and negative 6y. So that is fully factored. Moving on to the next. 3c times w squared minus 5 and plus w squared minus 5. Do realize that this is two sections, right? And those sections, what separates it really this plus sign right here. So what did the two sides have in common? They have a w squared minus 5 in common. And if you take that out, that GCF of w squared minus 5, what are you left with? Well, you're left with 3c. And over here, it's kind of weird, isn't it? There wasn't anything in front of it like there was this one, the 3c in front. So 3c plus what? Because there wasn't anything in front of it. Well, plus 1. Fully factored. So now that we know how to factor out a GCF that is a binomial, right? What they had in common was a binomial, a function instead of just a number. Now that we can do that, we can learn a method called factoring by grouping, and that's when you have a 4-term polynomial. When you have a 4-term polynomial, identify if there's a GCF between all 4 terms, and from there, separate the front and the back 2 terms. Okay, group the front and the back together, and factor out a GCF from the front 2 terms, factor out a GCF from the back 2 terms, and then if what's left, if the 2 terms share a common binomial factor as what's being left, factor out that binomial. So what does that even mean? Well, let's see. So factoring our 4-term polynomials, factoring by grouping, let's practice. 3a, 6b, negative 2a squared, negative 4ab. I was thinking they might all have a 2 in common, but they don't. So there's not a GCF of the entire polynomial. So once I've looked for GCF, now I'm going to group the front and the back. And when I'm looking for the GCF for the front 2 terms, I really just ignore this back half. If I was working on a whiteboard, an expo marker board, I would literally put my hand over this right here and forget about it for a minute, because it doesn't matter whenever we're looking for the GCF between 3a and negative 6b. So 3a and negative 6b have a 3 in common, and if you factor that 3 out, you're left with a minus 2b. So now that we've factored out the GCF from the front two terms. Now I'm going to focus on the back two terms to see if they have a GCF. And again, if I were at a whiteboard, I would literally put my hand over that left side because I'm not worried about it right now. I'm just worried about the right side, okay? So 2a squared and negative 4ab, they have a 2 in common. They also have a factor of a in common. And I guess I'll carry down that sign that was in front of the 2, so a positive 2a. And if you factor that out, you're left with, well, 2a squared divided by 2a is a, and negative 4ab divided by 2a is negative 2b. Well, now that I kind of step back and am looking, notice that what we were left with on both sides is a minus 2b. So that could be a GCF, or that is the GCF. And if you factor that out, you're left with 3 plus 2a. 4-term polynomial factored using grouping. Let's try that same thing again here, because this is 4 terms. There's not a GCF between all 4 terms, so I'm going to group the front and the back. 6x squared and 4x, they have a 2 in common and an x, and I am left with 6x squared divided by 2x is 3x, and then negative 4x divided by 2x is just a negative 2. So now I'm going to look at that right side, negative 15x plus 10. I'm going to pull out a negative since that leading coefficient right there is negative, and then 15, the leading coefficient right here, the 15 and 5 have a, 15 and 10 have a 5 in common. If you take that negative 5 out from negative 15x and positive 10, you would be left with a positive 3x and a negative 2. So notice, again, what I'm left with is 3x minus 2 on both sides. So that's our GCF. And if you take that out, you're left with 2x minus 5. 18a cubed b minus 9a squared b squared 2a plus b. All 4 of them do not have a GCF. So I'm going to group the front and the back. 18 and 9 have a 9 in common. A cubed, a squared have a squared in common. B and b squared have a b in common. You would be left with, okay, so 18 divided by 9 is 2. A cubed divided by a squared is a. B divided by b just goes away. Then negative 9 divided by 9 is negative 1. A squared divided by a squared is 1. B squared divided by b is b. I could have just said 2a minus b. Okay, so now on that back group, negative 2a and positive b, always if that leading coefficient is negative, factor out a negative, okay? And then 2a and b don't have anything in common, do they? But still, you need to factor out that negative 1. And if you do that, you would be left with a positive 2a and a negative b. How ironic. 2a minus b is what I'm left with on both sides. So if I factor out that GCF of 2a minus b, I am left with 9a squared b minus 1. This is fun because this is the first 4-term polynomial that we have that we're going to actually get to use that first step, which was look to see if all 4 terms have a GCF. They do this time, and it is 6, 6, 9, 9. It's 3, right? Everything has 3 in common. So if I pull all 3 out, I'm left with 2x squared y plus 2x squared plus 3y cubed plus 3y squared. So all I did was divide everything by 3, okay? So now I'm looking at the first group and the back group, okay? So 2x squared y and 2x squared have a 2 and an x squared in common, and you would be left with y and a positive 1. How am I getting this? They both had a 2x squared in common, so 2x squared y divided by 2x squared. It's just y. 2x squared divided by itself, 1. Let's move on to the other side. 3y cubed and 3y squared have a 3 and a y squared in common. And you would be left with, okay, so 3y cubed divided by 3y squared is just y. And then 3y squared divided by 3y squared divided by itself is 1. Don't forget the GCF of the whole thing, okay? Now, when we grouped our front and back and took out the GCF of each, the GCF of the front, the GCF of the back, what I was left with, again, was the same thing. So with that 3, I can also factor out a y plus 1. And I'm left with 2x squared plus 3y squared. Okay, and for these last two, we have some more specific instructions. Number 20 says factor out a 1/3 from 4/3 h squared minus 2/3 h plus 1/3. And basically, I mean, you can literally type in your calculator 4/3 divided by 1/3 and 2/3 divided by 1/3 and 1/3 divided by 1/3 and get the answer that way. But when you pull out a 1/3, you're just left with those numerators. But that's how you pull it out. You divide every single part by that GCF or that fraction. And then on the last one, the formula for the formula S, 21W plus, it's not 21W, that's 2LW plus 2HW plus 2HL represents surface area, so S, of a rectangular prism with a length L, width W, height H. Factor out the GCF and write the equivalent formula in a factored form. It's not a 4-term polynomial, so I'm not going to group it. I'm just going to factor out the GCF of the trinomial. So they all have a 2 in common, don't they? What would you be left with? An L and a W, and a H and a W, and an H and an L. How do you like that cursive?